Let's take a look at two examples where a block has been placed on an incline and see if we can determine from the information given whether the block will move. So here we have a block, 1.8 kilograms, sitting on the incline. And of course, from our previous discussions, we know certain forces are acting. We know that there is a gravitational force pointing straight down. We know that there's a normal force pointed perpendicular to the incline. And we know that there is a frictional force pointed up the incline. I don't know right now if it's a kinetic friction or a static friction, so right now I'll just call it F. In order to figure out whether F is kinetic or static, I need to determine what the value of the parallel force is due to gravity and what the maximum value of static friction is. And these are the two numbers that I'm going to compare to decide whether the block actually moves. The parallel force can be found looking at the weight times the sine of the angle. So that would be 18 newtons times the sine of 20 degrees. That turns out to be 6.16 newtons. The maximum static force would be mu sub s times the normal force, which in this case would be mu sub s times mg cosine of theta. So making sure I use the right value of mu, 0.48 times 18 newtons cosine of 20. That value comes out to be 8.12 newtons. Now again, this is the maximum value possible. It's kind of like this is your bank account. It's like you have $8.12 in your bank account, and someone's asking you to pay enough to keep the object in place. And the cost is this right here, 6.16. Do you have enough? Yes. That means things stay in place. The block does not move. Block does not move. And why is that? It's because the maximum amount of friction is greater than the force trying to pull the object down. 8.12 is greater than 6.16. Now, if I was talking about money like I was a second ago, if this was my bank account, and if it was going to cost me $6.16 to keep this block in place, would I pay $8.12? Well, no, I'd only pay enough to keep it in place. Same thing with friction. It only gives out what it needs to give out. And so the cost of keeping this object in place, the amount of friction, the actual frictional force, is just going to be enough to counteract the parallel force, 6.16 newtons. Now let's take a look at a similar question, but that has different values to it. Okay, in the same way, I need to look at the key numbers, the force that's pulling the object down the incline, and the maximum value of static friction. So this would be mg sine of theta, or 18 newtons, times the sine of 43 degrees. That turns out to be 12.3 newtons. That's how much I need to keep this block in place. Calculating the maximum frictional force, so 0.48 times 18 newtons times the cosine of 43. This comes out to be 6.32 newtons. Okay, so the question is, does the object stay in place? No. This is what I have in the bank, 6.32 newtons. That's not enough to pay up. Okay, 12.3 newtons is needed to keep this block in place. So the block moves. Now if the block moves, then what we just calculated is not all that valuable in terms of numbers. The block moves because the amount of friction needed is not there. Okay, we need 12.3 newtons of friction to keep it in place. But we only have 6.32 possible. So if the object moves, then we switch gears and we need to now calculate friction a different way. We need to calculate the value of kinetic friction. So now we would use mu sub k times the normal force, or mu sub k times mg cosine. So 0.32 times 18 newtons cosine 43. And we find that this number, like we would expect, is smaller than the maximum static friction, only 4.21 newtons.